Okay, let's do some reflections. So first I'm going to reflect this triangle over the y-axis. So here is the y-axis. So maybe you can imagine kind of folding the paper in half over that line. And if I had painted this triangle and it was still wet paint, then it would leave a reflection. It'd be kind of flipped over that line that way. Okay, so here's how we can do this. I mean, you can kind of, some people can just visualize it, but if you're having trouble with it, you can just take the points and reflect them one by one. So here's point C, and so I can see that's 1 unit from the y-axis. So I'm going to go straight to the y-axis, and I'll go another unit out the other side of the y-axis, and that's where C prime is going to end up. Okay, here maybe I'll use red so it's a little clearer. Okay, and then I'm going to do the same thing with the other point. So I can see point B is 2 units away from the y-axis. So if I go 2 units past the y-axis over here, that's where B prime is going to be. Okay, and then A, I can see that's, and you don't need to draw the dashed lines, I'm just trying to show you how I'm doing this. That's 3 units away, so I'm going to go 3 units out here. That's going to put me right there, and here is A prime. Okay, and then we just connect the dots, and we have a beautiful reflected triangle like so. Okay, and you can see it looks like it's congruent. It's the same size and shape, it's just reflected. So if your triangle comes out, looks warped or squashed or something like that, then probably you made a little mistake. Okay, all right, so we can write the coordinates. Let's go ahead and get the coordinates. We've already got these plotted. So C prime is going to be the point 1, 1. A prime, let's see, that'd be 3 right, 3 up. And B prime would be 2 to the right, 4 up. Okay, and you can also, there's a little pattern that is going to emerge here when we're reflecting over the y-axis. So if you compare these points, like these 2 points, hey, they have something in common, right? So do C and C prime and B prime. So all that's changing from A to A prime is the sign of the x value. Okay, and the same thing happens on all of these points. The y value stays the same because they're at the same height, but the horizontal position is the opposite. So it's going to change sign. Okay, so anytime you're reflecting over the y-axis, it's going to follow that pattern. So if this is an original x-y pair, once you've reflected over the y-axis, the x is going to change signs. The y will remain constant. Okay. So you could memorize that rule, but also, I don't know, I like to just do it visually, and then I'm sure I didn't remember the rule wrong. Okay? All right, so let's try the same kind of thing. This time our line of reflection is the x-axis, so we're reflecting over this line here. Okay? So yeah, here's the x-axis, right? We're reflecting over that. And then I'm going to do the same kind of thing. So C is 1 unit above the x-axis, so I'll go 1 unit below. There's C prime. A I can see is 3 units above the x-axis. So if I go 3 units below, that puts me right here. And then B was 4 units above, so I'm going to go 4 units below, straight down there. And here's B prime. Okay, and if we look at these coordinates, a pattern is going to emerge as well. Oh, let me finish drawing my triangle there. Let's see, this is, let's see, it's going to be -1, -1. Okay, so when you look at what's different here, the x's are staying the same because A and A prime are at the same horizontal position, but they're at different heights. So the y's change, right? If you look at those 2 y's, same thing here. And there, right? So if you're writing a general rule for reflecting over the x-axis, if you have your original x-y pair, once you reflect it, the y will change signs, the x will remain constant. Okay, so even if you didn't have a graph, if you just knew the ordered pairs, you could quickly figure out what the ordered pairs would be after the reflection. Okay? All right, so maybe you want to pause it and try This one, this is going to be reflected over the x-axis. I'm just going to get to it. So just, there's the x-axis reflecting over that. So A would end up 1 unit below. Okay, B is 2 units below, so I'm going to go 2 units above. I'm crossing over the x-axis, the other side. Okay, and now this is kind of interesting because C is right on the x-axis, so C prime is going to stay put. It's going to be right on top of my original C. Okay, so that's going to be 2, 0. I'm drawing my triangle. So this can sometimes throw people off because my original triangle and my new triangle overlap with each other. But that's okay. Think of this as the orange line being like a pole that this triangle is attached to, and it's just going to swivel. It's going to turn like I don't know, a flag on a flagpole or something. Okay, so it just turns around. So yeah, that C stays where it is. The B flips over, the A flips over, and it ends up something like that. Okay, and in all of these, the Y is changing signs. So, and you know, the opposite of 0 is 0, right? 0 doesn't have a sign, so it makes sense. So I could multiply it by -1 and it stays the same. Okay, so there's our reflection over the x-axis. Okay, so next up, this is a little throwback to some algebra. We're gonna graph some lines, some linear equations, because we're not always going to be reflecting over the x-axis or the y-axis. We might reflect over lines like these ones, so it's really important that you know how to graph these lines. Okay, so these two often get mixed up, x equals 2 and y equals 2. So one of them is a horizontal line and one is a vertical line. You can just memorize which one is which, and that's great if you can do that, but I find a lot of people forget. And here's a method that you can use if you forget. When I see x equals 2, I'm just going to make up some different ordered pairs. So my x is always going to be 2. My y can be whatever I want, so I'm just choosing nice small numbers, some small integers, okay? So these are, notice all of those points have an x coordinate of 2. So let's start plotting those. 2, 0, 2, 1, 2, 2, 2, 3 would be on 2, 4, and pretty quickly I get the idea, oh, if I graphed all of these points, I would get a vertical line. So that's x equals 2. It's a vertical line 2 units to the right of the x-axis. Okay, and we can use the same kind of strategy here. I'm going to just make up some ordered pairs, whatever I want, as long as the y is 2 here. So I'm going to use nice numbers. And all of these, the y coordinate is 2. Let's plot those. 0, 2, 1, 2, 2, 2, and in no time, I've reminded myself, oh yeah, this is a horizontal line. There we go, okay? All right, y equals x are gonna be a bunch of ordered pairs where the y and the x are the same, like 0, 0, right? And for 0, 0, the x and the y are the same, or 1, 1, or 2, 2. Or -1, -1, or -2, -2. And so what you end up with is a line that goes through the origin at a 45-degree angle. Okay, you can also think of this, if you think of this in y equals mx plus b form, you'd have this. So your y-intercept is 0, then you got a slope of 1, so you go up 1 to the right 1, up 1 to the right 1, so forth. Okay? All right, and this is the same kind of deal. So I'm going to just think about this. So my y-intercept is still 0, okay, but this time my slope's -1. So I'm going to go down 1 to the right 1, down 1 to the left, to the right 1, or I can go up 1, left 1, up 1, left 1, and now I get another 45-degree angle line that goes to the origin, but this one's going downhill because I got a negative slope, right? Okay. All right, so let's move on to some more reflection problems. So now we're going to reflect this triangle over the line y equals 1. So anytime if you're reflecting over the x or y axis, you don't need to graph the x or y axis, but if it's any other line, you should really graph that line when you're doing these reflections. So the line y equals 1, that's going to be all of the points that have a y coordinate of 1. Okay, so 0, 1, 1, 1, 2, 1, 3, 1, and so forth. Oh, and look, this is the wrong coordinate here, so I'll have to fix that. This should have been the point 2, 1. I'll fix that on the note-taking guide. Okay, all right. So, this is bothering me. 2, 1. There we go. Okay, so this was the line y equals 1. Okay, we're going to reflect over that. So I can see A is 1 unit above that, so I'm going to go 1 unit below that for A prime. I can see B is 2 units above the line of reflection. I'm not looking for how far it is from the x-axis. I'm looking to the line of reflection. It's 2 units above that. So I want to go down another 2 units from there. Here's B prime. And then C is right on the line of reflection. So C prime is going to stay in that same place at 2, 1. Okay? And then and hopefully you can kind of visualize how that would be a reflection over that line. Okay? There's no nice rule for memorizing what's going to happen to the xy pairs because it just depends where the line of reflection is. So unlike the first set we did. So let's see. This is the point -2, 0. This is going to be -1, -2. And that one stays at 2, 1. Okay? All right. So let's try reflecting over the line y equals x. Okay, so first let me plot y equals x. Okay, so here is my line. Okay, there's a very light grid on this paper that I'm using, but you probably can't see it in the video. But what you can sometimes do is use the grid. So I'm going to reflect those points over this line, and it's really hard to see, but this would be one diagonal box away from the line of reflection. So I can go one diagonal box like that. Okay? So here's where C prime is going to be. All right, and then when I'm looking at B, again, it's really hard to see on here. And don't worry if you can't see it because I'll show you another method. But this goes through 2.5 boxes diagonally. So I'm going to go, there's a half box, and then here's another 2. Okay, and B prime is going to end up right here. And then looking at A, it's 2 diagonal boxes, so I'll go 2 diagonal boxes this way. Here's A prime. Okay, so all right. So what if you just have a sketch on a piece of binder paper, or you can't see the grid? You can't really count diagonal boxes then, right? But that's okay because when we're going over y equals x, there's another method. Okay, so my original C was at 0, 2, and then this ended up at 2, 0. 0, 2, 2, 0, 0, 2, 2, 0. So those are pretty closely related. They're actually just flipped, right? So when you're looking at B, it's at -2, 3, and guess what? This ends up at 3, -2. Okay, and the same thing here, the xy pair just swaps, so this is going to end up at 1, -3. Okay, so that is worth memorizing. When you're reflecting over y equals x, if you have your xy pair, and you want to just reflect whatever point over the line y equals x, you just flip around the pair. So if you had, 5, 7, you'd end up with 7, 5. You just flip the pair, and then you can find those ordered pairs really quickly. Okay? Okay, let's try, oh, you know what? I've got another typo here on the next problem. So I'll fix this in the note-taking guide. I wanted to reflect over the line y equals -x. So let's go ahead and do that. Okay, so y equals -x. is going to go through the origin again, but with a negative slope. So it's going to look something like this. Okay, so I can use the diagonal box method again. So let's start. C is actually the easiest one to see here. It's a half box diagonally. So if I go a half box the other direction, I'm going to end up down here. Okay, and then let's think about that ordered pair. So this is going to be 0, -1. Okay, so it's not quite just swapping it, right? Because one of the signs changed as well. Okay, now let's look at this. A is actually going to end up where B is, and B is going to end up where A is. Okay, so this is going to be a little bit of a pain to graph here, but A prime is going to be right on top of B. So A prime is going to be -1, 2, and then B prime is going to be at -2, 1. Okay, and then if I plot this, okay, so maybe I'll shade this in. So this shaded one is my new triangle. So I can see it is flipped over that. Now, when we're looking at the relationship between these points, okay, so I can see, hey, the zeros switched spots, and so did the ones, but then the 1 became -1, okay? When I'm looking at the A's, my original A and my final A, the same kind of thing happened. But now I can see that they actually both changed signs, okay? So when I'm going over y equals -x, any point, it's going to change positions, but also change signs. Okay? So for example, if I had, I don't know, 7, -2, well, the -2 would move to the front, but it would switch signs. The 7 would move to the back, and it would switch signs. So 7, -2, if you reflect that over the line y equals -x, would reflect onto 2, -7. Okay, this next problem, I'm going to reflect over y equals x. So you can pause it and try it out if you like. I'm just going to get to it. So first, I'm going to graph y equals x. There it is. Okay, and even if you've got a really simple sketch and you're not in graph paper, you can think, oh, it's just going to switch positions here. Okay, so rather than 2, 4, I'm going to have 4, 2. That's going to end up right there. And then, so yeah, this is 4, 2. And then instead of 2, 5, I'm going to have 5, 2. 1, 2, 3, 4. Oh, need one more tick there. And rather than 0, 4, I'd have 4, 0. Okay, make sure you put the little ticks to show what your final image is as opposed to your original one. Okay. All right, so I'm actually going to do, there's some more problems up the top of the page, but I'm going to do this one right to the right here because it kind of fits better with what we're just doing. Okay, so we've got something called a glide reflection. And a glide reflection is just going to be a translation followed by a reflection. Okay, a glide is kind of the same thing as a translation. Okay, so I'd call this a translation reflection, but all the books call it a glide reflection for whatever reason. But we're just going to do both of these things, okay? I've been reflecting triangles because it's a little bit easier to see them reflected, but you could just reflect points or line segments or quadrilaterals, whatever you want, right? So we're just going to do these piece by piece. So first I'm going to translate segment AB over over this vector. So this means I'm going to go right 2, down 1. So let's take point A. I'm going to go right 2 units and down 1 unit. Okay, and then I'll do the same thing here with B. I'm going to go right 2 units and down 1 unit. And there's B. Okay, now I've only done phase 1, right? So I've got the 1 tick here. All right, and then the second part is reflecting over y equals 2. So I'm thinking of all of the points with a y coordinate of 2. 0, 2, 1, 2, 2, 2. There's y equals 2, okay? So now I'm going to reflect this, this purple segment here is going to reflect over that line. So see, that's 1 unit above, so I'll go 1 unit below. And then this is 2 units above, so I'll go 2 units below. Okay, now this point here is going to be A double prime because 2 transformations have happened. I did this, and then I did that. And then this is B double prime. Okay, and so here is where my segment ends up. And you don't necessarily need to say what the coordinates are when you're halfway through the glide reflection, but you should really say them where we end up at the end of the problem. So this is 2, 1 for A double prime, and this is 4, 0 for B double prime. Okay, and then we've just done a glide reflection, and the ticks tell me the whole story. Looking at this, I can see, oh, there's after phase 1, here's after phase 2, after 2 transformations. Okay. All right, and the last thing I want to look at is lines of symmetry. Okay, so I'm going to go up to the top of the screen here. So I've got, this is supposed to be a square. Okay, I freehand sketched this so it doesn't look perfect. But this says sketch the lines of symmetry and then how many lines are there. So a line of symmetry is a line that you can fold something in half and it will map onto itself. Okay, so if you imagine a line going right down the middle of this square, this is supposed to be a square, like so, I could fold that in half and it would fold nicely onto itself, right? Kind of hot dog style. But I could also fold this like so. So there's another line of symmetry, right? So then I want to think, are there other ways? Well, yeah, you could fold this on the diagonals. So I could fold it like that, or I could fold it like that. Okay, I'm going to put in one more line that is not a line of symmetry, but then I sometimes see people try to do something, and I'll do this in pencil. Try to do, I'll erase this in a second. Okay? If I did one like that, this corner would end up sticking out over there when I tried to fold it in half. So that pencil line I just drew does not work. Okay, so you have to think, if you fold it on the other diagonals, that'll work out perfectly because those 2 corners will fold together nicely. Okay, so also I see some people say, draw those correctly, and then when it says how many are there, people go, oh, 1, 2, 3, 4, 5, 6, 7, 8. Well, then you just double counted all of the lines, right? So when I say 1 down here, that's the same line as in the top there. So be careful with that, right? So I've got the 2 diagonal lines, that's 2. Then I got the vertical line, that's 3. The horizontal line is 4. So this is going to be 4 lines of symmetry here. Okay? So let's look at this next figure, which is meant to be a rectangle. Okay? So just like with the square, we could fold it right down the middle, like so, with a vertical line. We could also fold it like so. Okay? So I've got 2 lines of symmetry right there. Some people will try to fold this on the diagonals. It's not going to work though. Okay, so I'm going to show you why that diagonal does not work. I came with a model rectangle. Okay, so here's my model rectangle that I have. Okay, and I'm going to try to fold this over the diagonal. So hopefully, so this is not going to be perfect, but I think it'll be enough to get the idea. Okay, if you try to fold a rectangle over a diagonal, you're going to end up with something like that. You'll have corners sticking out. It doesn't fold perfectly in half. Okay, so that means for a rectangle, that line's not going to work. Okay, and this is a very visual thing. It's not something that I have an easy rule for how it's going to work, but imagine actually folding it in half over the line and think, well, would the two halves fold up perfectly like the palms of your hand would and match up? Okay, so this is actually only going to have 2 lines of symmetry, not 4 like a square would. Okay, that's the end of the section. I'll see you next time.